Hello, everyone. This is Dual Credit Biology 1, Unit 1, Lecture 3. Today's lecture will cover sections 1.6 through 1.8. If you could go ahead and grab your lecture presentation, and you can open up your books to page 11. So this lecture is going to be talking about the nature of science. Let me go ahead and pull up the PowerPoint for us so that we can follow along with it. I just think it's always good for me to have something to kind of not get off on a tangent. So we're going to be just looking at the science of nature and really the nature of science, how we do science. And so this, of course, is going to go through some of that stuff that you already know about, scientific method. So we're going to kind of skim through that pretty quickly. So you definitely want to go back in and read those sections in your book. And we will have an assignment at the end of this, a POGL about analyzing data using charts and graphs, just as a good refresher. So we know the scientific method is an ongoing process. We are constantly making observations, thinking of what we want to know, how can we test it, what do we think we're going to find out, and then when we find it out, did that answer our question, or do we need to go back and do it again? And so scientific method is constantly going on, and we use it in everyday life. I use the scientific method for all kinds of things, household chores. What's the best way to get this done? I wonder if I try it this way, if it would be better. So those are the things that I like to do with scientific method as an ongoing process. So as we go through this, I have a video that talks about inductive versus deductive reasoning, which are two different thought processes when you're doing the scientific method. This is linked in the Google Classroom, so you can go watch it, of course, at a later time. So moving on through, these are some things that I want you to know. When you talk about the scientific method, judging the quality of information before accepting it is called critical thinking. It's when you think smart. And so that's always important. And that's something that you get as you get older, the ability to do critical thinking. The scientific method, as we said, is a constant cycle of making, testing, and evaluating, making, testing, and evaluating. And we have to determine what we're looking at, and we do that with variables. What are we testing, and what happened because we tested that? So the independent variable is what I'm changing, the dependent variable is what I measure. And then you need to know that natural systems in what's out there in the world, it's not a clear-cut scientific method. When we're in class and we do a science experiment in the lab, we have one variable that we're measuring because of one variable that we're changing. But we know that in the real world, it's multiple variables coming from all different ways, and it's totally different. That's why right now during COVID, it has been so frustrating. It's because there's so many different variables and people don't understand that we're seeing science happen. 10 years from now, we'll look back at the data and everything will make so much more sense. But right now, because so many things influence the outcomes and there's so many different variables, it really changes what we are finding. So when we analyze experimental results, we typically do that by using numbers. We want to make sure that we have good data that represents what we're trying to do. And so we do something called a subset. Subsets are data points or data plots that we can use, read through, and then make a generalization about the whole thing. Sometimes we have what's known as a sampling error. It's when we see this subset has one thing and this subset has one thing, but this third one's got something crazy. Usually that's some kind of weird sampling error, and we may need to run that again. It's always good when we do science experimentation that we always do multiple trials to make sure that it wasn't just a fluke. Checks and balances are important. Checks and balances allow other researchers to come in who are objective and look at the observations and say, how did you get this? Blah, 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 blah. And so they can talk about things and then they can make changes as needed. Sampling error allows us to repeat things over and over and over again to see if we get that error again. And so by doing that constant trials, it limits the amount of errors that we eventually get when we explain our data. Um, we do a lot of calculations, and you are going to do a lot of math in here because statistics are very important when we're looking at scientific data. And then scientific or science is using a community. The community looks at information. They all make their own critical thought process, work with that data, and then they explain it or test it on their own. Once again, that's something we're seeing right now with COVID. There's so many different scientific groups and scientists who are all taking part in the study of this virus. And right now, we're seeing a lot of conflicting information because they're all doing their own experimentation, their own research at one time. So one more thing about the nature of science is we have something called theories versus laws. And in science, when something can't be proven, it is what we call a theory. A theory is something that we have revisited over and over and over and over and over again, and it can never be proven wrong. But there can be questions still. A law means that it's happened over and over and over again, and there are no more questions. And so we have a lot of theories that we talk about in science, and a lot of theories we talk about in biology because of that. Here is a video clip about the difference in a theory and a law by the Amoeba Sisters. It's linked in the video, linked in the Google Classroom, and I encourage you to go and watch that because they explain it really well. All right, and then the last thing I want to talk about is science versus pseudoscience. I tell people that pseudoscience, in my opinion, is Facebook science. You have to be very careful about Facebook science because they work differently. Science takes a problem, investigates the evidence, and goes where it leads. Whereas pseudoscience knows what it wants and it manipulates the data to get that conclusion. You have to be extremely careful with people who are doing science um, under the disguise of being a pseudoscientist. We see a lot of pseudoscientists right now during this time, and a lot of things that that you can see is that they're very hostile to your criticism. They think that they're the only one who has the right answer. They don't use a large group of people to back their information. And if they do use someone, it's someone that they've chosen. And so pseudoscience does not use science. They may talk scientific, but they're not being scientific. And so in the next few days, you're going to have a current event assignment. And I hope that you will find a good scientific article, preferably about what we're going through right now, and explain to me why you know that that is science and not pseudoscience, because pseudoscience can really sway some people to make decisions or to believe things that are not factual. Okay, so we have now finished up the chapter. I'm going to encourage you to go back, review through the presentation notes, review through the videos. If you've not read your chapter, you must read your chapter because there's a lot of information that I have not covered specifically in lecture, but are important, important facts. And then I would definitely read through my chapter review on pages 20 and 21. There is an assignment following this. You'll find in the Google Classroom on analyzing and interpreting data. It's another POGL, so you'll follow that procedure just like before. If you have any questions, please contact me and I will be glad to help you. You can email me or text me, and I will see you later. Bye-bye.